So let's get started. It's TreeMap tasks turn. So I'm starting from creating main, and also I'd like to add tasks here. I think we can implement all first three tasks. They are quite simple. Oops. So I'm going to copy them and create a new class. Let's name it TreeMap. Simple TreeMap tasks, and let's add our task here. So first task is to create a TreeMap and add five keys with values, and to print out sorted data. Okay, private map names, it's string for names and integer for no marks, integer map, and let's import map in and let's create an object and constructor public TreeMap tasks, and in this constructor I'm going to initialize map as a new TreeMap. So also I need to add 5 values, 5 pairs there, and so let's create method for this, protected void add, and string str and integer grade. Yes, actually not this, str name and integer grade. And this I'm using put method here, name and grade. Actually, also I'm going to create a printing method, and I don't need to do anything special to make this data sorting, because in a TreeMap, when you add a pair, it sorting during insertion and by key value, and so the TreeMap is always sorted in ascending order. And of course it stores this order while being printed. Next map for each key value okay, let's make it nice. Name plus name and concatenated no name here as a key plus grade plus value. So let me close my practicing classes, and so let's create our object TreeMap tasks, not cache, task map, and initialize it as a create it as a new TreeMap, and let's add 5 pair create let's imagine grades. We can have grades from 0 to 10 here. Olga 6, and map add Anton 4, and also map add Ivan 1, and one more here, map add N and 3, and let's print it out. And here N, Anton, Ivan, Cat, Olga looks correct. So the second is to find a min and max key. Actually, because it's a sorted TreeMap, so the minimum key is always the first one and the maximum is the last one, and we have special method for it. Min and max. We don't need any arguments here. So it's first. Cannot understand why I can't use map or first key. What's wrong here? Because yes. No? Yeah. Map first key. So let's make it string max, and let us assign, or not max, actually is min here, and also let's create max and assign map last key here, and also let's print it out. Sort min key is, and let's concatenate it with min, and plus, and last is, and max is, and concatenate it with max. So let's check it. It was made print. Let's add an empty one in here and here as well. Looks like something wrong here. Yes, actually, because I didn't call this method, min and max. So min is n and max is Olga, exactly as it was expected to be. And the last one, let's imagine that we have employee and ID. Actually, I don't think it's I need to create another map. So the method is we have a special methods, lower key and higher key, which help us to find nearest, next, greater or smaller key, and for these methods we take a key as an argument, and this key is excluded. That void next largest, and I think we need to I need to find an ID here. Okay. So yes, it looks like I need to create another map. Okay, so let's create a class, employees, and let's create a TreeMap private TreeMap. No, just a basic Java TreeMap. And so the task is, I think I should use an ID here as a key, because usually usually ID is unique, while the employee surname, for example, can be not unique across the company. And the second, because we only have methods to find bigger or smaller key, not a value. So integer and string. Employee constructor, public employees, and initialize our TreeMap employee as a new TreeMap. Good. And let's add adding method for adding, protected void add employee, and integer ID and string surname, and employee put ID and surname. Okay, and again we need printing method, protected void print, no arguments, and map, not map, employee of course, for each employee, key for each pair of key and value. We will print key plus space plus value, and let's add an empty string here. And the last, I need a function method to find nearest bigger largest k. Protected void next larger, and I'm going to take ID as argument here, and let's say employee hierarchy from ID. And let's call it integer. Integer next larger, and employee higher ID, and let's print it out. Next for ID plus ID plus next larger ID is plus next larger. Okay, let's call it from main. I'm going to comment my current code. So let's create an object of class employees, new employees, and let's add maybe 3. Oh, not it. It's it. 4 island and map play. Oh, 7 create and map add and play. 3 and n. And let's call our method here next larger and for 3, and let's test it out. For id 3 next larger is 4. Good, exactly what I expected. So let's try additional tasks. Okay, let's create new class. I want to make it simple. Merge tree maps. Here is the task, right? Right, correct. Tree maps. So let's make it static. The private static tree map. No, not task, tree map, just tree map. Integer 3 1 and private static tree map integer 3 2 and let's initialize them in a static block. So 3 1 new tree map, and let's 1 5 6 7 tree map integer. I cannot do it like this way. Okay, and 3 2 new tree map integer no, not okay, and let's add method main here, and let's add t1 output 1 1 and 3 1 1 put 2 2 and 3 2 put 2 and 2. It's a duplicate, it should be removed. 3 2 put 3 3. Oh. something wrong here? No. And let's 3, 1 for each key value, and let's print. Actually, I'm going to merge 3.2 with 3.1, and 3 number 1 will be resulting 3. So key plus space plus value. Okay, so it's time to write merge method. Private static void no, not void. TreeMap integer. As a result, I'm going to have a 3.1 integer, and let's also take TreeMap as an argument. Integer merge 2 trees. What's wrong here? No return. 1, 3, 1. So okay, and actually method put all merge 2 trees and remove duplicates. So it looks like it's all I need. So return 3.1. Should I merge 2 trees? TreeMap v2 and merge 3 maps, merge 2 trees and 2 as an argument. And so let's check. So 1, 2, 3, no duplicates. And the last task. And the last task is the TreeMap cache. Here is our task. Well, actually, I think my solution will be almost the same as it was for other maps. So let's start from creating cache or creating TreeMap private. Let's make it static again. Static TreeMap long integer cache, and let's initialize it. And I think also we need a the constant static long lifespan. Static long. What's wrong here? And let's initialize everything in our static block. So I'm initializing cache as a new TreeMap. And lifespan as 5 seconds. So let's create main, and in main added I'm going to add some several pairs. Okay. So I'm going to add system current time as a key, and some integer number as a value. I am adding numbers in ascending order just to simplify testing here. And let's override method put and add expire removed here, I think. So let's create a method for removal expired pairs. So it will be private static void remove expired. No arguments here, and let's introduce long now here. No system current time. And so while cache is empty, while cache is not empty actually, and if a difference between now and the time we inserted value is bigger than a lifespan, we will remove this element. So now minus what? Minus cache get Now minus what? Now, oh, it's a key, so I need a key, right? Right, it's a TreeMap. Actually, it's a TreeMap. Cache, first key, bigger, then lifespan, cache, remove. Oh. Cache. Actually, cache poll first entry. Poll first entry. Good. Looks like everything is working just nice here. So I need to add printing method. Private static void print. So cache for each key value. I'm going to print out key plus space plus value and print an empty line. So lifespan is 5 seconds. So let's add don't know thread sleep. Yes, sleep 4. Actually, I don't think I need it here. And then print and then thread. Actually, let's make, yes, I usually make pauses between adding thread, sleep, and print. So here we go. 1, 2, 4, 6. So I'm expecting here 2, 3, and 4 values. And it's too complicated, I think. 3, 4, yes, here 4. And Let's run it this way. I think I can got an exception here because I think 3, 4. Yes, because actually I have, yes, because I wrote remove expired, but I am not calling it. So let's make it private static void put new. Add new and no, I'm going on the take value here and num value here and as an argument, and I'm going to generate key automatically. So it's a cache put system current time and num, and that's it. And let's yes, and before this I'm going to call remove expired, and also I'm going to call remove expired before printing. So not put yes, I can just add new the new and add new and here is tree and again add new. So let's start it again. Looks like I made a mistake somewhere. So add wait, add wait, add let's print on each step. Print and print and print, add print and print and print. Okay, let's run it one more time. It's much more interesting. So it's a first, it's correct, yes. Second, It's correct. Yes. And third, and after third, and after fourth, and this is, and 4 milliseconds. So I deleted this. Oh, let's make it shorter. 1 and 1 and 1 and 1000 again and 1000 again. So let's check it out. Okay, so lifespan is 3. So I create one, I wait 1 second, I add second, and wait 1 second, and I add 3, third, and 1 second. And so before print, 1 second, so 1, 2, 3, so 1, 2, 3. So here I print and I should already remove the first one, right? And here previous, and here only 4. Yes, it looks, and nothing here, and it looks like it works correct. Okay, so I'm done here.